Good, welcome back. Today we are going to look at what we call complex number. So far so good. We have been looking at different types of numbers: the whole number, the fraction number, the decimal numbers, the integer number, the terms of financials, rational, irrational, real numbers, number sequence, logarithmic number, exponential number, radical number, modular number, modulus, number system. Today we want to look at complex number. Let me tell you something. This guy called complex number, everything inside this guy, they are inside there. He now have one more properties that others did not have. And then we're going to look at it. So we're going to look at the complex number, the meaning, how to plot it in the graph, and then the basic operation. We are looking at the elementary parts. Okay? When we grow mathematically, we go deeper. Okay? Let's get started. Good. So complex number. Now, what is the standard form of complex number? Let's say we have x plus I, y. Okay? This x is the real number. And what are the real numbers? You remember real numbers? This real number can be whole number, can be decimal, can be fractional, can be integer, can be rational, can be radical, can be logarithmic, can be a lot. What we have been looking at. Now, what is different now is this guy. Why do we call this one complex? All this guy is called complex number, but one part is called real, and the other part is called imaginary number. Imaginary number. Imaginary number. Why do you call it imaginary number? Something you imagine. Just think about it. Something that is not solvable directly using real numbers. Now we have x and y, right? If you want to plot this guy, if we have, this is x, right? And this is y. So this part is called what? The real numbers. Don't forget, when we are showing real number, we need to show it from straight line, right? 0, minus 2, 1, 2, continue, right? This is for real numbers. All the real numbers are inside this place, right? Now, imaginary number now have its own numbers, making it two-dimensional. Are we together? So we use this one as a real number, which is what we have been doing. We call it number line, right? Call it number line. But now we now have imaginary number. This y is what? The imaginary. The imaginary numbers. So I is it. This I, it was make it to be imaginary. Now, how do we get number like this? How do we get number like this? Don't forget, when we are introducing numbers, radical number which is square, if you say root of 4 is what? 2. Perfect square, right? But now, if there is a negative side, minus 4, if you press your calculator, it will give you an error because of this minus. So if you have a problem that gets to this level, how do we solve it? We have to employ Mr. Complex number to simplify this guy. So how do we do it? Very simple. We simply decompose this guy. You remember the decomposition? Separate. So I can write my root of minus 4 into the root of minus 1 times 4. This and this is still the same. Do you agree? Good. So, following the radical number rules, I can separate this guy because they are in the same root. I can say the root of minus 1 times the root of 4. Do you agree with me that this guy is the same with this guy and is the same with this guy? This one has only real number. There is no problem about that. This is where we have problem because of this negative side. First, we decompose it. We separate it. Now we know that root of 4 is what? Is 2. Right? Now, what do? in mathematics, if you have a problem like this, what we do is we represent this guy as I. So I is what? The negative of root 1. The negative. Because there's no calculator. So anyway, we see I minus 1, we call it root 1. So this guy, we can write it as what? 2I, which is the root of minus 4 is root of minus 4 is what? 2I. Do you understand? Now it is out of the square root. Are we together? This is very, very important. This is very, very important. So the simplification of root of minus 4 is 2I. Let's solve more problem to make it easier. Are we together? Let's solve. Now let's look at an example. We have the foundation already, right? That the standard form of complex number is x plus I y, right? This is standard form. This means this is real number and this is imaginary number. Everything are called complex number. Good. Now, the question says express the root of negative 16 in standard form, which means we need to find what is the real number here and what is the odd number. Okay? So, the right solution. We know that the root of minus 16 can be decomposed to the root of minus 1 times 16. Right? We agree. So, we can separate this. So, we have the root of minus 1 times the root of 16. Right? We separate it. We know that the root of negative 1 is what? Is I. Is I. Times the root of 16 is what? Is 4. So I times 4 is what? 4I. Is it the final answer? No. We have to write it in standard form. The standard form is what? A plus IB. Or you say Y plus I. What is important that it look like this. So this place there is no number without I. So in our case is what? Is 0. It's 0. Plus, and this is our imaginary number. So we have 4I, or you say I4. It doesn't matter. Either you say I4 or you say 0 plus 4I. It's the same. Right? I4, 4I. Rice and beans and rice. Everything go to the stomach. Second question. The roots of negative 24. Decompose, we have the root of minus 1 times 24. Separate it, we have the root of minus 1 times the root of 24. Now, can we find the perfect root here? We have a decimal point, right? But if you remember our previous class, on radical number, we can decompose this guy. One with perfect root, the other one without perfect root. So what can we do it? Is 24. So 4 can be one of the decomposition. So we can have the negative of minus 1 times 4 times 16. Sorry, 4 times 6. Because 4 times 6 is what? 24. This one is having perfect root. But this one is doesn't have. Doesn't matter. At least one of them should have. If one of them cannot have, you can just stop here. So finally, the root of minus 1 is what? Is I. Times the root of 4 is what? Is 2. This one is not perfect root, so still keep it under the square root. So finally, our real number here is 0 plus I times 2. We have 2I, the root of 6. And this is the final result. It's getting easier, right? Very easy, right? Good. Now, let's solve this one. This is plot graph. I told you that we have x-axis, which is what? The real numbers. Y-axis, which is what? The imaginary numbers. Now, it's a plots or sketch or draw or represent the complex number. This guy, this guy, this guy, this guy on the plane, on the complex plane Complex plane means on a coordinate plane. So let's have this. I want to put everything in one graph. Okay. So let's do it like a sketching because there's no perfect graph here. So let's say this is our y-axis. This is our x-axis, right? So this is y, that is the imaginary part. This is x, the what? The real part. The center where all of them they meet is called center is 0, right? From this guy, moving forward is what? 1, 2, 3, 4, 5, and so on. Moving backward is what? -1, -2, -3, -4, -5, and so on, right? This is not new. We know this one for our number line. Now, what is a little bit new is the y-axis. Going up is what? Positive. Coming down is what? Negative. It's obvious, right? Going up, you are ascending. Coming down, you are descending. Remember? Under number sequence. All this mathematics is foundational. Make sure that you don't have any cockroach in your cupboard. Learn them. Now, going up is what? Minus 1, 2, 3, 4, 5, and so on. Of course, I am solving at 5. It doesn't mean that I have to solve at 5. I can continue until the number I have here. -1, -2, -3, -4. I want to solve at -4 here. So I don't think that I must solve at 5 every time. No. Because I can see that the highest real number here is 2, is here. Real number is here, 3. Real number here is -1. Real number here is 2. So which means I don't even need 3, 4, 5. The complex here is 4. The complex here is 3. The complex here is minus. The complex here is 4. So now let us find it. The first one, 2, on the real number. 4 on the imaginary number. Of course, this is what? The imaginary number. Everything on this line, they are imaginary. So now let us go and look at it. 2 is for real number. This is 2. So these 2 belong to this line. 4 is on the imaginary number. 4 is here. Now we have to check where both of them meet. This guy is going up like this. This guy is coming over like this. Let us do it. Let us do it. This guy is going like this. This guy is coming like this. Right? They meet at this point. Both of them meet at this point. The point they meet is what? The real number versus the imaginary number. If you want, you can write it in full by writing the real name. The real name here is what? 2 plus 4i. So at the center, this is the center. So you draw a line from here. Go here. Sorry, my line is not that so straight. Sorry. Or it should be straight line. So you can use your ruler to draw it. So this point belongs to this A. So this is A. B, 3. What? Imagine here is what? -3. 3 for the real number, -3 for the imaginary number. So where did they meet? Let's go and check it. This guy, come down, come down, come down, come down, come down. This guy, go by the side, go, and they meet around this place. Right? They meet around this place. This point they meet is what? 3 minus 3i, which is belong to B. Right? So take a ruler and draw a line. And this is the coordinates of the second part. The third one is -1 for real, -2 for imaginary. So this guy come, and this one come, and they meet around this place. They meet here. So draw a line arrow pointing here. This what we draw here is what? Minus 1, minus 2i. This belongs to C. Right? And the last but not the least, minus 2 belongs to real. 4 belongs to the imaginary. Minus 2 going up, 4 come by the side, they meet here. They meet here. So draw your line and this charge here. What is the name of this? Minus 2 for real and for I, which belong to D. And this is called complex plane. So we turn the complex number to complex plane. Plane means 2 dimension. Okay, on the plane, not plane that fly on the surface. Okay, it looks nice, nice picture. You can pose and take picture with it. Oh. Okay, let's go. Let's be more serious. Let's be more serious. Good. Now, simplification of power I. Don't forget, we say that I is what? The root of negative 1. Right? Now, what if we have I square, I cube, I power of 100, I power of 1 million? How do we express it? Or how can we express it? You agree with me that this is square, which means power of half. So if this square root comes to this place, it is called squared, right? So which means I can say I squared is minus 1. You agree with me? Yes. I square root become square, right? We put the other side. So if this is true, if I is root of minus 1, which means I squared is what? Minus 1. If I squared is minus 1, we can express it more. I cube with what? I squared times I. You agree? I squared, I cube is what? I squared times I, because it's power of 1. Under the law of indices, you have the power. So this guy gives us. So which means I squared is what? Minus 1 times I. So which means we have negative I. Mathematics is very sweet. I cube is the same as what? Negative I. What if we have I to the power of 4? You agree with me that I to the power of 4 can be decomposed to I squared times I squared. You agree? This guy still produces. And I squared is what? Minus 1. So I can say this is minus 1 times minus 1. If you don't like this, you can write this in the same thing. Okay? Minus 1 times minus 1 is what? Is 1. It means I to the power of 4 is standard 1. I will together. I will together. This is very important. This is very important. So, we can have more problems. Let's say we have I to the power of 5. I can express as what? I to the power of 4 times I. Right? Meaning, I power of 4 is what? 1. Times I is I. Means I to the power of 5 can give me I. What if you have more? I to the power of 6. I can write as what? I to the power of 4 times I squared. Since if I have more than 4 power, I can make it standard 4 first. Why? Because 4 is always 1. I power of 4 is always 1. So this guy is the same with this guy. So I can say this is 1 times, what is it? Minus 1. This minus 1. So I to the power of 6 is what? Minus 1. What of I to the power of 7? I can write as what? I to the power of 4 times I cube. Which means 1 times, what is I cube? Minus I, which is minus 1. Which means I to the power of 3 is the same thing as I to the power of 7. What of I to the power of 8? This is like I power of 4 times I power of 4, right? Which means this guy is the same thing as I to the power of 4 squared. Do you agree? Power of this is the same. I can see 2 of it. And I to the power of 4 is what? 1. So I can write 1 squared, which is 1. Are we together? So you can see how I join it together. So I can say I to the power of 9 is what? I to the power of 4 squared times I. Because I know that I to the power of 4 will always give me 1. And anything power of 1, it is 1. So obviously everything here is what? 1. So if everything here is 1, so we have 1 times I, which is what? I. Are we together? Okay, let's make it, let's deal with more. Okay, let's do one more and later increase the number higher. This is so small. Let's make it higher. Okay? Okay, so let's make it more bigger. We have done 1, 2, 3, 4. Let's just do 35. Don't forget, the standard form that you should keep in mind is this guy. Okay? I power of 4 is 1 standard. Because anything power of 1, it is 1. So if it's 4, so what you think of now is, if this is 35, what do? You decompose 35, which means divide it by 4. What remains? Now that will give us what? I 4 times 8, because 4 times 8 will give us 32. 32 minus 35, that is plus 3, right? 35 can be decomposed as 4 times 8 minus plus 3, right? So I can write this again this way. Why? Because I can write it as I to the power of 4, 8 times I to the power of 3. This guy and this guy is the same. How do I know? My knowledge of law of indices. Exponents. Exponent number. Remember? Good. Now, I power of 4 is what? 1. So we have 1 to the power of 8, which is what? 1. So if I don't put 8, it's okay. Because I know that this is 1. Anything 1 is carried, it is 1. So 1 times this. What is I power of 3? It is minus I. So 1 times minus I is what? Minus I, which means I to the power of 35 is equivalent to minus I. The second question. This is 102. First, divide by 4. 102 can be decomposed as 4 times 25 plus 2, right? Because 4 times 25 is 100. 100 plus 2 is 102. Yes. So, we can write that I to the power of 102 is the same as I to the power of 4 times 25 plus 2, which is the same as I to the power of 4 power of 25 times I squared, right? Because I is common. We want to multiply. All this is law of indices. Now, everything here is what? Is 1. Because I to the power of 4 is 1. 1 to the power of 25 is 1. And then what is I squared? Is minus 1. So we have minus 1 as the final result. So which means I to the power of 102 is minus 1. You see, that's very easy. So solve more problems. Check our workbook and solve. Good. Now, as usual, basic operation. You know, there is no way we have not do basic operation. Addition, subtraction, multiplication, division. They are basic everywhere. We use it every day. Let's go there. Now, let's look at the basic operation of complex number. We like basic operation, right? We say This guy, we are already waiting for your basic operation already. Good. Let's start with addition. Let's say we have, let's say the first equation, we have, let us z is equal to a plus b I z1 and z2 is, let's say, x plus I y. I can write it front or back, it doesn't matter. Now I am looking for z1 plus z2. I'm trying to look at the two. So this guy is what? A plus bi plus z2 x plus xy, right? Now, what did I do? Is collect the like terms by putting all the real numbers together and all the imaginary number together. This guy and this guy, they are real. This and this is real. Put them together, and this a plus x. This is a real number. This number are imaginary. Put them together. So I can say a plus x is real, plus b plus y, they are imaginary. You see, I put all the real and I put all the imaginary. Don't let me talk in abstract. Let us solve some example. Let's say we have 2 plus 3i plus 4 minus 2i. Open the bracket with minus. So we have 2 plus 3i plus, open this, we have plus 4, plus open this, we have minus 2i, right? We know, open the bracket already. So what is left? Put all the real numbers together. This is real. This guy is real. Put it one side. This is imaginary. And this is imaginary. Put it together. So what do we have? 2 plus 4 is what? 6. This is real. 3i minus 2i is what? If you like, you can see it's I. So put them together on one side. Right? Same. Then it's really imaginary. So 3 minus 2 is what? 1. That is plus 1i. But we don't need to write 1. But just need 6 plus I. And the I is what? The complex, the imaginary. Let's have one more example. Let's say, let x equal to 4 minus 3i and y equal to 6 plus 2i. Find x plus y. X plus y is what? What is x? 4 minus 3i. Right? What is y? It's x. Y is what? 6 plus 2i. Right? Collect it. The real numbers. 4 is real. 6 is real. 3i is imaginary. Plus 2 is imaginary. Right? 3 is imaginary. If you open this bracket, I jump one step, which I think is obvious. And then 2 is imaginary. That is imaginary. So we have 10. 3 minus 3 plus 1. You are plus 2. You are owing 3. You have 2. So if you pay 1, you have 1 left. Right? This is under integers. So if you mix that video, please go and watch it. This is addition. Okay? Now let's look at subtraction. I will use the same idea. Z1 is this, Z2 is this. Now I am looking for negative. Z1 minus Z2. I'm using the same thing. So Z1 is what? a plus bi minus z2 is what? X plus iy, right? I'm using the same idea. The only difference is that this place I am adding, but this place I am subtracting. So collect the terms, open the bracket, we have a plus bi, x minus plus minus, right? Now collect the like terms, a minus x, the real, b minus y, the imaginary. Now, example. I want to use the same example. 2 plus 3i, but now negative 4 minus 2i. So, solution, collect the like terms, real. So I have 2 minus 4. These are real. Imaginary. But before that, I think we have to be careful. Then I don't want to jump step. First, let us open the bracket first, so that we don't miss anything. So this is 2 plus 3i minus times 4. We have minus 4. Minus is what? Plus 2i. We have to be careful with minus. That's why I don't want to jump step. It's easy to jump step here because it's addition, not a change. But my negative change. So all the real, 2 is real, minus 4 is real. All the imaginary, 3 is imaginary, plus 2 is imaginary. So 2 minus 4 is what? Minus 2 for the real. Imaginary, 3 plus 2, 5. And this is for the imaginary. So you have to solve the real separately. You have to solve the imaginary separately. Be careful, please. The last example on subtraction, I want to use the same thing. This place, they said x is this, y is this. Now we want to find x minus y. X is what? 4 minus 3 minus y is what? 6 plus 2i, right? X is this guy, y is this guy. This place we had, but this way we want to separate. So open the bracket, we have 4 minus 3i minus times 6 minus 6 minus times plus minus 2i. Now, as usual, the real together, the imaginary together. So we have 4 minus 6. These are the real numbers. Plus minus 3 minus 2. These are the imaginary. I put plus here because it doesn't change. So negative. So finally, 4 minus 6 will give us minus 2. Minus 3 minus 2 will give us what? Minus 5, right? Minus 5. I. And this is addition, subtraction. So who can guess the next step? Multiplication and division. Let's go there. Okay, now multiplication. We have looked at addition, subtraction, now multiplication. The first question here. This is just a scalar multiplication, right? We have 3 of 6 plus 2i. That is, 3 is multiplying everything inside the bracket. As usual, 3 multiplied by 6, right? That is 18, right? 3 multiplied by 2, that is 6, what? High. So the real number increased to 18 and the imaginary number become 6. Okay, let's do something more serious. 2i, 4 minus 6. Now 2i is multiplying 4. That is what? 2 times 4 is 8. And there is I here. Minus 2 multiplied by 6 is 12. Now I is multiplying I. This means that I power of 1 times I power of 1, which is what? I power of 2. We have to simplify this guy. What is I power of 2? Don't forget that root minus 1 is I, and I squared is what? Minus 1. I is, this comes here, I squared is minus 1. Remember this? If not, check this simplification again. So which means this I squared, we can write what? Can write minus 1. So which means the imaginary become real. Wonderful. And the real here becomes imaginary. So minus 12 times minus 1, we have 8i minus minus equals 12. So if you like, you can leave it like this, or you say 12 plus 8i. That is, you write the real first before the imaginary. Getting interesting, right? Let's go to the third question. The third question, it's easy, but we have to open double brackets. We have 4 plus 3i 2 minus 5i. So which means to multiply this one, we have to multiply this by this, right? After, multiply this guy again by this guy, this by this, the same guy by this guy. So which means everything here must multiply everything in this place. This is very important. This is very important. So let's do it. So we can decompose this guy as 4 multiply 2 minus 5i, because 4 is multiply this guy, plus 3i is multiply 2 minus 5i. So we piece this into 2. What do we do? 4, you see, 4, 4. Multiply this and this guy. So we have this. 3i, multiply this guy and this guy, we have this. So this guy now becomes something like this. This becomes something like this. Math is very sweet, right? But that is very interesting. Now, since we have break it down, we can now open the bracket. So what we did here, 4 times 2 give 8, 4 times 5 give 20, and I is by the side, right? Now come here, 3i times 2, it was 6i. Plus minus is minus. 3 times 5 is what? 15. And I times I is I squared. And I squared is what? Is minus 1. Okay, let's write it down. So it doesn't say where it comes from. So I can say 8 minus this and this is the same. Minus 20 plus 6. They have I. They are both imaginary. So I can join it together. So minus 20 plus 6 will give us what? Minus 14i minus 15. I squared is what? Minus 1. From the simplification of power. Simplification of power. So we now have 8 minus 14i plus 15. So finally, this plus this, we have 23 minus 14i. And this is the expansion of this guy. D. 3 minus 4i times 3 plus 4i. There is something I want to prove here. I want to prove conjugates. We learned from radical number. We have been dealing with number for a long time. This is the conjugate of this, right? That is, if it's minus, it becomes negative. Remember? Conjugate. So, the same thing, multiply these 3, multiply everything here, and this minus 4, I multiply everything. Okay? If you agree, quickly. This is 9 plus 12i minus 12i minus plus minus 4 times 4, 16. I times I squared. What do you notice? If you find the conjugate of a number, they cancel. So what do we now have? 9 minus 16 minus 1, which is 9 plus 16, which is what? 25. Wow! If you multiply complex number with its conjugate, it gives us real number. Very good question for interview. If you come for interview, you want to teach mathematics in your school, I can now interview you that, okay, if you multiply complex number with its conjugate, what will you get? Will you get complex or will you get real number? You will only get real number. Yes. Changes. The last but not the least. Minus 1 minus 2i squared. This means 2 times of this. That is 2 places. So we can write this as minus 1 minus 2i minus 1 minus 2i. Right? Square, if it's cubed 3 times, right? Power of 5, 4 times. Power of 100 times. That would be too crazy. But there's a method we can use to solve that kind of problem. I will teach you when we get there. Come on. Just follow. Just make sure that you watch this every day. Yes. Okay, let's go. The composite, we have minus 1 times everything here. Minus 2i times everything here. So open the bracket. Minus 1 times minus 1, 1. Minus minus plus 2i. This is finished, right? Be careful of minus, 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 minus. Minus 2i times minus 1 plus 2i minus minus plus 2 times 2, 4, I times I squared. And I squared is what? Minus 1. So now, by now, you should know. I will not be writing it again. I squared is what? Minus 1. Keep it in your memory. So what do we have now? 1 plus 4i minus 4. So this is minus 1. Minus 1 times 4 is. So finally, all the real together. 1 minus 4 is what? Minus 3. This is a real number. Plus 4i. This is imaginary number. Always put it in standard form. Write it real first before imaginary. If you write it other way, no problem. Nobody can crucify you. But just to make it nice, you know, we learn real for complex. And that's the end of multiplication of complex number. Now the last but not the least. Guess division. Nice. Let's go there. Okay. Now division. But before we go to division, let's look at conjugate again. Now, I explained it a little bit in our previous lesson. So conjugates, just like what we learned from radical number. If you have 3 plus I root 6. What is the conjugate of this? The conjugate of this is change this number, symbol to the reciprocal of it. So this is plus, the reciprocal of plus is what? Negative. So the conjugate of this guy is 3 minus I root 6. So you can say the conjugate of this guy is this guy. Okay? The B. The conjugate of what do we have now? Negative 7 over 10 I. This guy, first write it in standard form. In standard form, to go up is 0 minus 7 over 10 I. Right? This is kind of standard form. So the conjugate now is what? This is negative, it becomes positive. So we have 7 over 10 I. Don't forget, it's the complex side that will change. The complex will change. Okay, the last one. See, the conjugate of minus 3 plus 4i. What will change? The complex. This is plus, it change. The conjugate of minus 3 plus 4i is minus 3 minus 4i. Minus 3 minus 4i. Now, let's solve the real problem. The real problem, divide 1 plus 5i divided by 2 minus I. To find this, remember our radical number. We have 1 plus 5i over 2 minus I times, now find the conjugate. What is the conjugate of 2 minus I? That is 2 plus I, 2 plus I. So you multiply the conjugates of the numerator by the numerator and by itself. Remember this? Radical number. We did it when we have root. The radical number. So this guy is seen as 1 plus 5i, 2 plus I, divided by 2 minus I, 2 plus I. So open the brackets, just like what we did in our previous lesson. So this is what? 1 into 2i plus 5i into 2i divided by 2 into 2i minus I, 2 I, right? We express this exactly what we did before. So now open it. 1 times this, 2. 1 times I. 5 I times 2, 10i. 5i times I, don't forget, I squared is minus 1. So I don't want to waste time here now. 5i times I is 5i squared. I squared is minus 1. So I can write minus 5. Divided by 2 times 2, 4. 2 times I, 2i. Minus I times 2, minus 2i. Minus minus, minus plus, minus. I times I squared. And I squared is what? Minus 1. So I can write this one to be plus 1. I told you, if you multiply complex number with its conjugate, what happens? Remain real number. Remember? So, keep it. Now, real to real. Real to real, that is 5 minus 2 minus 5, that is minus 3. That is for the real. For the complex, I plus 10i, that is 11i, divided by 5. 4 plus 1 is 5. If you like, you can stop it. If you like, you can separate it. Let all the real, all the complex. So we have what? Minus 3 over 5. This is for the real. Plus 11 over 5. This is for the complex. And don't forget to put I to show that it is a complex. And then this is the final results. This is the final part of basic complex number. I use the word basic because we still have more advanced complex number. Okay? But at this level, it's okay. When we grow,